Am I the only one that didn't know how we measure atoms? Well, buckle up, we're diving into atomic mass. Atoms are tiny pieces of matter, but they still have mass. To keep things simple, scientists use the Unified Atomic Mass Unit, or U. This unit is defined as 1/12 the mass of a carbon-12 atom. So, for example, a hydrogen atom weighs about 1.0078 U, and an oxygen atom is around 15.9949 U. Simple, right? But here's the twist. Most elements in nature are mixtures of isotopes. To find the average atomic mass, we sum the masses of the isotopes, each multiplied by its fractional isotope abundance. And when we talk about mass per mole of atoms, we're talking molar mass, measured in grams per mole. Since 1 gram equals 6.02214 times 10 to the power of 23 U, the molar mass of carbon is 12.01 grams per mole. Pretty cool, huh? Now you know how atomic mass works. The relative atomic mass, R, is a dimensionless physical quantity. It is the ratio of the average mass of atoms of an element to 1/12 the mass of an atom of carbon-12. Hence, the relative atomic mass of carbon is 12.01. In periodic tables, the relative atomic mass of the element is usually given below the symbol of the element.